All right, this lesson is a quick revision on atomic structure. You should have learned this in S1, S2, first year, second year, in your general science lessons. But it's always worth just revisiting to make sure that everybody's on board with it. So atoms. Atoms are the fundamental unit, the smallest possible unit that can have chemical properties. And every atom has its own physical properties as well. But so once we go below the size of an atom to particles, subatomic particles, protons, neutrons, electrons, they no longer exhibit properties. They just have the property of the neutron. They just have the property of the proton. They just have the property of the electron. Right? But once you put those three things together and make an atom out of it, and you start building in more and more protons and neutrons into the atom and more electrons, every time you go up by one proton, you get a change in properties. And these are what we call the elements. So every element has a certain number of protons in it, and that is equivalent to its atomic number. The periodic table is arranged on the basis of proton number. Okay? But where do these things exist in the atom? Well, there's a whole lot of history about this and a whole lot of misunderstanding, and there's still probably some misunderstanding about exactly what electrons do in an atom. But what we now know is that an atom is formed from a nucleus. So we have a nucleus in the center of an atom. And in that nucleus, for example, the hydrogen atom, the nucleus is made up of a single proton. And hydrogen is the first element that came into existence after the Big Bang, and it's the simplest element. A single proton, atomic number 1. Now, after hydrogen got together and ended up in stars, and stars lit up and began nuclear fusion, we got new elements. And we're just going to put in another one. So, in this particular nucleus, we have 2 protons. And we have 2 neutrons. Zero and 0. 2 neutrons, 2 protons. Okay? Now, that's the nucleus. The protons and the neutrons are bound together in the nucleus. And the nucleus itself is very tiny compared to the size of the whole atom. I'll just explain that in a minute. But you need to remember that it's very tiny compared to the size of the whole atom, but it contains all the mass of the atom, pretty much. The electrons, essentially the electrons go together with the protons to make one mass unit, but because the proton is so much bigger than the electron, we consider the proton to be the mass unit. All right. So helium has a mass of 4, 1, 2, 3, 4, and it has 2 electrons. There are 2 protons, atomic number 2. It has 2 electrons. So flying around the outside of this atom somewhere, we have 2 electrons. Now, it's almost impossible to visualize this, but the electron shell around the nucleus is vastly bigger than the nucleus itself. Vastly bigger. So these electrons are in what we call orbitals and shells, energy shells, around the nucleus. And if I was to take a golf ball and make that the nucleus of my helium atom, the electrons could be anywhere within 5 miles of here. So, and the electrons are almost non-existent. They're incredibly tiny. They're just little tiny particles of matter with negative charges. So we have our golf ball, we have our electron shell around us that's about 5 miles. So that means that atoms are mostly space. But the trouble is when atoms come together and interact with each other, the electron shells meet. And because the electron shells are both negative, they crash into each other and essentially bounce, like taking 2 north poles of 2 magnets, pushing them together. They want to bounce off each other. And if you push a magnet along at the other one, it'll bounce along. So the electron shells repel. Now, that's the visualization of the atom in terms of scale. But what is it in terms of arrangement? So if I was to take the protons and the neutrons, let's take our protons will make blue. Okay, so we've got our nucleus, there's a blue proton, there's another blue proton, we'll just do helium for the moment. Here are some neutrons, they'll be green. Yeah, so we've got our nucleus, and the protons and neutrons make the nucleus. Okay? Protons and neutrons go together to make the nucleus, and there are various experiments. You can look up the history of the discovery of the atom and the structure of the atom in various other videos. But the Rutherford's gold foil experiment shows that the nucleus is really a very, very tiny proportion of the whole atom. And our electrons live in an electron shell around. Now, for the purposes of National 5, we just pop the electrons onto the edge of the first shell. So when we draw an electron configuration, we pop it onto the edge of the first shell. Now, generally, in chemistry, we don't worry too much about the nucleus. The nucleus doesn't take part in chemical reactions. It's only giving chemical properties to elements, and it gives mass to elements, but it doesn't really take part in chemical reactions. The electrons are the things that take part in chemical reactions. So while the protons and the neutrons form the nucleus, we need to remember that it's the electrons that are doing chemistry. They're doing the chemical reactions. So if I move up the periodic table, so I could replace this nucleus with the symbol, the symbol for the element number 2, which is helium, 2 protons, atomic number 2, and helium. That He represents a helium nucleus. And we can draw this much more simply by just drawing circles around the helium. Okay, so we'll take our helium nucleus and we're going to draw a circle around it. Now, some people draw a circle around that to represent the nucleus, but it can be confusing. And we're going to put 2 dots or crosses. You can put crosses or dots on. Some people prefer dots, some people prefer crosses, to represent the 2 electrons in the first energy shell. Now, that first energy shell is full. First energy shell equals 2 electrons. E negative is an symbol for an electron. Okay? Let's move up to lithium. The next element in the periodic table, 3 protons. It has to have 3 electrons. First shell is full. We put in our second shell. This is why lithium appears on the next row of the periodic table, because each row of the periodic table represents a new electron shell being added to the atom. Lithium has 3 electrons. We pop it into a new shell. Let's skip along to neon, which is at the end of period 2 of the periodic table. Neon has 8 electrons in its outer shell. 8 electrons. And that fills up the second shell. The second shell can hold 8 electrons. Eight electrons. Okay? Now, we move on to the next element beyond neon, which is sodium. And sodium gains another electron because it's gained another proton, and it has to go into a new shell. Sodium is in period 3 of the periodic table, and it has 1 electron in its outer shell. So sodium has a 3rd shell, period 3, and again, to cut a long story short, we can skip along to the end of period 3, which is argon. And we'll fill in. Argon now has 18 electrons, and we have to put 8 in the outer shell. Now, the funny thing is that this third shell can hold a lot more electrons, and when we do higher chemistry we'll understand a little bit more about why that is, and why, for some reason, argon is incredibly stable with 8 electrons in its outer shell. So this is an incredibly stable structure with 8 electrons in the outer shell. The outer shell can hold 18 electrons. So let's just, third shell equals 18 electrons, but 8 is stable. Now, a number of reasons for this, but we're going to go to the next element on the periodic table after argon, which is potassium. Let's take potassium. Now you'll find that potassium is on the next row of the periodic table. It's in period 4, and that means that it has 4 electron shells. So rather than fit another electron into the third energy shell, what potassium does is it skips onto the 4th before it comes back to the 3rd. So we get our 4th energy shell, and potassium adds an electron out there. Which means that potassium can lose 1 electron, fall back and be very stable, but that's another story. So potassium now gains 1 electron, and the only other element that we're interested in the periodic table is calcium, which is the next one after potassium, element number 20, 20 electrons, and the 20th electron is there. So as we build up the atomic number from protons, we build up the number of electrons equally in a stable in a neutral atom, and we add the electrons in shells. You can add 2 electrons to the first shell, maximum, 2 electrons to the second shell, maximum. You can get 18 electrons into the third shell, but we're actually going to add 8 electrons for stability, and argon is incredibly stable with 8 electrons in its outer shell. And then potassium and calcium add an electron, or 2 electrons, to the 4th shell. And that is the electron, the structure of the atom as far as we're concerned in chemistry. Generally, remember that you get protons and neutrons in the nucleus, but they are represented by the chemical symbol, usually. You won't have to draw protons and neutrons in a diagram. Just put the chemical symbol in the center. Some people do put a circle around this. It'd be good if it was in a different color, but when it's in black or in your normal pen, it just gets confusing. It gets confused with the electron shells, and it particularly gets confusing if your element is oxygen. That means you get 3 circles in the middle. So it's a bit of a mess. So just stick your, what have we got? This is calcium. Stick your chemical symbol in the center, and then add your electrons correctly to the shells as you go.